Okay, is there any question which I didn't ask you?
I think the only thing I would like to stress is that when we talk about the anthropic principle and the anthropic reasoning, we're always saying, well, there's a fine-tune, there is a selection effect to allow for observers. And it is important to understand that the term observer is very vague, because the word anthropic comes from it's the Greek word for man or human, which is a terrible choice because that was Carter's word. Brandon Carter introduced anthropic. But whatever it is, these coincidences aren't associated with human beings in particular. And it's a pity in that sense that Carter used the word anthropic, because it does make it sound very anthropocentric, you know, we are special. From my perspective, all the anthropic principle is saying is that the universe is fine-tuned for the development of complexity. Stars and galaxies. You know, by complexity I mean you've got to have chemistry, stars, planets, and different complex structures. I don't see there being anything specific to humans in the argument. So the only thing I would say is that I prefer the word complexity principle to anthropic principle, because the anthropic principle makes it sound much more theological than it need to. It makes it sound as though the universe was made specially for us, you know, which seems to be going back to the anthropocentric view. But if you see the anthropic, these fine-tunings as being generally related to the fact that the universe can evolve to produce complexity, I think that's a much more, well, plausible and sort of palatable view, because, you know, the remarkable thing about the universe is that as it evolves, you form ever more complex structures. You know, eventually after the Big Bang nucleosynthesis, you start forming like nuclei, protons and neutrons and deuterons and things like that. And then later on you get galaxies and stars which produce heavier elements, and then you produce biomolecules, and you get life, and then eventually from life you get brains, and and then eventually brains evolve into professors of physics, the culmination of complexity in some sense. So I mean, but the point is that to me, I just see observers in some sense at the top of this pyramid of complexity. And the interesting thing is the universe is tuned so this pyramid of complexity.
But doesn't complexity eventually die out? I mean, the universe inflates.
Of course.
It gets colder, darker, the stars die out long enough the black holes evaporate.
Well, that's true.
There's nothing left, and plausibly there are no observers.
Well, I mean, it depends on the long-term fate of the universe, but if we, for example,
assuming the value of
put it this way, if the universe is going to recollapse, which doesn't seem likely at the moment, but if the universe is going to recollapse, we build up our pyramid of complexity, and then as the universe recollapses, the pyramid dissolves. So that's one view, the pyramid of complexity builds up and dissolves. If the universe is going to expand forever, that's a very interesting question, what happens to the pyramid of complexity, because it doesn't obviously dissolve, because, I mean, it might do, because if you wait long enough, all stellar systems evolve to black holes, and black holes evaporate. So I suppose
yes, that's what I'm talking about.
Yeah, so I guess
we're in an
sense,
exponential here.
Yes, I suppose in the sense that if the universe eventually, everything just turns into black holes, which then evolve, then I imagine you're right. We have to say that this period of complexity becomes undone again. You know, that it dissolves, and then maybe we have another bounce, like in Penrose's conformal cycling model, and it builds up again. So maybe the picture we can have is this pyramid of complexity building up and coming down. But of course, that's on a huge time scale, and again, going back to a sort of Dickey type argument, maybe our observers can only exist for some tiny window of this huge length of time. So that's an interesting question.
So would you agree that the complexity principle, aka the anthropic principle, would you agree that that's just the idea that the universe has to exhibit some interval of complexity of sufficient length, and we're in it?
Yes, and that's a very interesting way of putting it, because if you look at the scales of structure that exist in the universe now, complexity only exists in a sort of intermediate range. You know, the universe is very simple on very small scales, and it's very simple on very large scales, but there's this intermediate regime where you get complexity, and that's spatially. So you're asking the question, well, does it also happen in time? So if I say the universe is very simple at very early times, when it's just quantum cosmology. What could be simpler than that? And then, joking, but then at the very late stage is where the universe has just dissolved back into vacuum again. It's very simple. So could it be that complexity only exists for a short window in time as well in space, which is a very interesting view. And so maybe that's the way of putting it. The complexity principle is saying the universe must be such that complexity can arise at least for a small window of opportunity.
Now, would you rephrase it as saying that observers could arise? I mean, both complexity and observers are rather poorly defined concepts, and could we restate it in terms of observers? If so, what is an observer?
I tend to regard observers as part of complexity, in the sense that with this pyramid of complexity, going up from chemicals to biochemicals to life to brains, I tend to think of consciousness as being somewhere at the top of the pyramid of complexity.
Now, does an observer have to be conscious?
Well, I mean, that's a deeper issue, but I mean, personally, I do think consciousness plays quite a crucial role here, but you don't have to take that view. I mean, you could just take the view that consciousness is a sort of passive thing, and you could say what's really fundamental is life and what I think you call an IGUS, which is an information gathering collecting. So I'm happy you could just call it that and avoid the use of consciousness at all. But whatever description you're using, I would say that represents in some sense the culmination of the complexity. So to me, I do see observers as going hand in hand with complexity. So although I said I would prefer to think of this as a complexity principle rather than an anthropic principle, in my own mind, I do think it really does have something to do with observers, and the fact that there are what you call, sorry, I've forgotten your acronym.
IGUS.
IGUS. So I do think IGUS are crucial.
IGUSs are a little more general, I mean, than things that are conscious. For example, there's a famous example of a thermostat.
Yes,
right?
yes.
A thermostat is certainly gathering information, using it, and acting on it. Is it conscious?
Oh,
well,
absolutely.
some people would say it has a simple level of consciousness.
I mean, the crucial question is, if you believe the anthropic principle is a selection effect, a selection principle, what is being selected for? Now, is it consciousness? Or is it professors of physics, or is it dogs? Is it mice? Is it termites? Is it just a robot? Is it just any irreversible detecting process like a Geiger counter? So it's completely vague what is really being selected for. Personally, I quite like the idea that it's something to do with consciousness and life, but if you just think in terms of complexity, it certainly doesn't need to relate to consciousness. It could be something much more basic, and the answer is we just don't know, because whatever your criteria is, I mean, I like your criteria of IGAS because it's sufficiently general. It covers robots as well as humans, and maybe it covers mice, I'm not sure, as well as men. But the point is, complexity, by using the phrase complexity principle, you're not committing yourself to anything, because this is a difficult question. Nobody knows the answer. Put it this way: if you were a robot, you would also apply the anthropic principle. You probably would have more leeway as to what the universe would look like than if you were imposing it on a professor of physics.
I don't understand the connection between complexity, which, after all, what is there are various measures of complexity. For example, the difference between the entropy of a set of histories augmented by the algorithmic information content. People have proposed such definitions, which depend on coarse graining, what you follow, and so forth, but they don't particularly require observers. That is, you can have, for example, you can have your pullover there, which is more complex than my pullover because it's got this pattern of diamonds on it, so it's a little further up the complexity scale than mine. What is it that, how do you get to observers from mere complexity, which is sort of just descriptive, right? It takes a long time to describe something like this.
Well, what I would say is that, because I have a personal prejudice that actually observers, and even conscious observers, are in some sense important here. It is important to ask that question. And let me put it the other way around. It seems to me clear that whatever consciousness is, it has to involve complexity. So we have to develop a brain which is able to receive information and have some form of memory and have some sort of gathering and utilization process. But whatever that requires, and of course no one understands how consciousness fits into physics anyway, but whatever that requires, it clearly has to involve some minimal level of complexity. I'm not defining complexity very precisely here, but whatever the brain is, we know the brain is probably the most complex thing in nature. Certainly it's the most complex structure we know of in nature, at least on this planet. And so I would say it is certainly true that consciousness does require complexity. And I even say rather fancifully, maybe brains are the culmination of complexity. But it certainly requires complexity. Now you're asking the question, does complexity require consciousness? And I would say no, not necessarily, because you can describe molecules and DNA as complex structures and there's no consciousness there. But what I would say is that in an evolutionary sense, probably this pyramid of complexity, once it begins to grow, I would hope that it rather naturally evolves fairly quickly to this culmination of complexity in the form of conscious observers. I mean, if you look at life on Earth, it took a long time for life to start off. I mean, we know the Earth is 4.5 billion years old. We know it took several billion years for the first self-replicating molecules to arise. But once they did arise, the process of evolution has happened on a relatively short time scale. In other words, and we've gone from the first, dinosaurs or whatever, we quite rapidly evolved up to the level of having human beings and professors of physics. So I like to think that once the pyramid of complexity starts to build up, it almost inevitably and rather quickly is going to end up producing consciousness. So although I don't think in principle consciousness has to I don't think complexity necessarily needs to involve consciousness, I do think there might be an argument that in an evolving universe, complexity may fairly naturally and fairly quickly, on a cosmological timescale, evolve towards consciousness.
But what is the basis for that? That would imply you understand biological evolution,
which of course
at a scale. Right, we don't.
My basis of that is purely asking what happened here on Earth. So you're quite right. I have no reason for extrapolating that.
Well,
and no one,
planet in many ways.
Well, and also you're right. We have no idea how the first biomolecules formed anyway. We still don't understand how life arose on Earth. So I certainly can't say categorically that wherever you have sufficient complexity, you're going to produce consciousness. But I'm just showing my prejudice here, because I personally do feel that consciousness is important to the universe. And that's why I like to think it arises fairly. Now, I guess I have got this sort of perspective that the universe has been tuned so that consciousness can arise, and therefore I'm prejudiced to the view that whatever complexity we are producing, it will naturally turn into consciousness at some point.
Well, I can't follow you there, right?
Well, and it may be wrong. I mean, there's an element of wishful thinking, but all I'm saying is on Earth, which is the one place we have data for, we know that once the build-up of complexity started, it did evolve towards human beings fairly rapidly.
But what about the statistics of planets, right? For example, there was a book a long time ago called Rare Earth, which argued that the most prevalent kind of planet would have nothing but pond sludge, right? And if it was in the habitable zone, that is some sort of life, but nothing beyond.
Yeah, well,
right, so
you see, saying that the universe is tuned for life doesn't mean that it's tuned to arise everywhere.
Right.
I mean, we certainly know that, there might only be one in, it might only be one in a million stars produces life, but then there are billions and billions of stars, so that doesn't really matter. I mean, there might well be anthropic arguments why you don't want life to arise everywhere. I mean, if every star had professors of physics, it could be a nightmare. I mean, you know, in the sense of the competition, we'll be being wiped out and eaten by our nearest neighbours and things like that.
Trying to get tenure in a galactic civilization filled with...
You would have to, yeah, you would have to apply for a job in another galaxy, which would be terrible. No, but I mean, seriously though, I mean, I do think it's important to emphasise that just because we're fine-tuned for life, it's fine-tuned for life somewhere, and it doesn't imply that life has to be everywhere. And Carter himself, for example, he has an argument that life is very rare in this universe. Carter argues that, in fact, we have an infinite universe, and that we are probably the only form, our planet is probably the only form of life in the entire observable universe. And so one has to be careful not to say, just because, when I say the pyramid of complexity, I don't mean that the pyramid of complexity has to work on every planet. I'm not saying every star system has to have a pyramid of complexity. I'm saying the universe as a whole is tuned so that the complexity can arise somewhere if other conditions are satisfied, because there are other conditions as well which are required for a local pyramid of complexity. The question is, can a pyramid of complexity arise somewhere, even if only arises rarely? I mean, after all, the fact that only a tiny fraction of stars may have life is completely analogous to the idea that only a small fraction of universes in the multiverse might have life. So to me, it's a fairly natural picture.
But I'd like to distinguish between your intuition, right, which you're clearly expressing here, and what are the facts, right, so to speak. What is the bottom line, the minimal thing we could state as a anthropic principle?
Well, I would say, from a physical point of view,
that's right.
I would say what's really crucial is you have to have chemistry. Yeah. I do think you have to have something like stars. Whether you need to have something like galaxies and stars. Now, you need planets, whether they can be life forms, Fred Hoyle's life cloud, which exists in interstellar space, maybe they could. So maybe you don't need planets. I mean, obviously I'm used to living on a planet, so I tend to think planets are necessary. But the anthropic arguments don't depend too much on planets. They do normally depend upon galaxies, and they depend upon stars. I would say another crucial feature is you have to have a deviation from thermal equilibrium. I think that's a common feature of the pyramid of complexity only arises because in some sense you get away from thermal equilibrium, because thermal equilibrium will always just doom you to a boring, homogeneity where nothing happens.
So you've explained very clearly these fine tunings, right? Most of which don't just involve numbers in the theory. What is the minimal level of structure that they imply? Not the maximal level, right? So you said stars.
Stars, I would say galaxies, stars. To be honest, I would say galaxies, stars, planets, and chemistry.
Okay, thank you. Well, I think we've